Excellent. So, Gareth, thanks again for joining us and talking to us about ABS and in general your journey into natural capital investments that you are doing. So maybe I'm going to refer to my notes and research that I did before coming to talk to you. Maybe one of the first question was related to natural capital. So you started with Beetle Capital back in 2008. So how did you find the motivation to actually go into natural capital side of things as compared to VC fundings where you can get much more shorter term gains? And what's the motivation?
I think the journey started before 2008. I'd spent 20 odd years in the insurance sector, in risk management, risk consulting, and broking, and at various times, was focused on the energy and power sector, and in the late 90s started looking at carbon both as a risk, but also an opportunity, and so the focus was really about if there is a price for carbon, what impact is that going to have? So obviously for carbon intensive businesses, industries, a price of carbon could have an effect on the valuation of those companies. On projects which were 20 to 30 years, what was the potential impact? Again, if they were energy intensive projects and there was going to be a price for carbon. And then looking at the other side of the equation, what does that mean for the companies developing the technologies that would basically be the solution providers in the decarbonization process that at that stage felt inevitable? And to cut a long story short, I ended up co-founding a company called Climate Change Capital back in 2002. And there were four of us at that stage, and over a fairly short period of time, we raised in excess of $3 billion. We had a $1 billion carbon fund, we had a property fund, we had a long-short fund, we had funds in renewable energy, and we had a private equity fund. And we were sort of at that stage sort of the leading environmentally focused asset management and advisory business. And it was very policy driven. We had a large policy team who really understood the nuances of this new carbon market. And in 2005, of course, Kyoto Protocol got signed, and everybody was very optimistic at that point about a sort of carbon managed future. And things looked to be very positive. Unfortunately, with the financial crisis, 2008, 2009, the carbon market, as was then constructed, imploded, and a lot of value was lost globally by many companies who had invested in that. I took advantage of a liquidity event in 2008, and that's when I left to set up Beetle Capital with a very clear focus on transitioning to a low carbon economy, driven partly by an energy security point of view, but also from the environmental perspective. So depending on what your view of the world was, it sort of didn't matter. We needed very significant changes in the way that we did things, manufactured things, sold things, used things, to reduce the amount of carbon in the atmosphere. So I spent a number of years working with funds and projects and early stage companies on the advisory side, looking to help those companies A, raise capital, and B, grow, and covered nearly every industry and every spectrum around that. In 2018, I was approached by a colleague and subsequently co-founder of ABS to look at helping a company raise capital. Their focus was They were a distribution business for bacterial products being manufactured in the US. And we ended up acquiring that business, established what was then Active Bacterial Solutions. We subsequently changed the name to Advanced Bacterial Sciences. And the business has been going for about 4 years now. We've had quite a few challenges through COVID and other just the normal issues you have with startups and a few not so normal. But today, we are a science-led business. We are 25 people, scientists based up in the northwest of England, near Lancaster. We have an innovation centre there, and our primary focus is on alleviating pollution. So we are looking to change the way that people manage waste, treat waste, and process waste of all types. And we do it in a natural way, in that we are doing essentially what nature does. The bacteria, which they break down waste, which is what they're doing themselves naturally, and we look at which of those consortia in any particular waste problem that we're looking to solve, which are the most effective. And then by looking at nutrient packages, how we can optimize the performance of those microbes in that particular environment in which they are operating. So we have a number of products for different sectors, some of which are being, in a commercial sense, being used, sold, and we have a number of others in various stages of development. So the built environment, we have a number of products. So anything which blocks a drain, whether it's a urinal or it's a toilet or it's a grease trap or it's just the piping infrastructure, we have products today that will basically digest those organic wastes. And we're developing a range, and the core products are preventative maintenance. So by using them, we are eliminating the chance of the blockages reoccurring, but at the same time, the bacteria are creating an ecosystem where it's healthy, and we're getting rid of the need to use the more toxic chemicals that are currently in use, which are not only bad for the environment, they're bad for health, they're bad for almost everything. But they work, they deal with the problems, but they do it in a way which is ultimately not sustainable. So we come from an environmental base. We're very focused on the health aspects of what we're doing. All of our products are non-toxic, non-pathogenic, and have no negative impact on people or the environment. And they are cost effective.
Understood. And I think one of the things that actually caught my attention was the natural part of it and the organic part of it, and actually using what's already happening in nature, researching on it, and then actually figuring out specific bacteria that actually can help with organic waste. Now, one of the questions that spontaneously came into my mind was, Gareth, at the time of founding Beetle Capital, had ABS come to you for funding or for acquisition in that matter, what would have been your stance? Because times have changed, right? 2018 and 2008, it were different times. And the focus, the regulations, the awareness amongst people, everything has shifted. Now people are more aware. People would appreciate something like ABS, right? The field of using bacteria for removing, say, for example, oil spillages and everything, that's something that has been existing. There have been industrial applications. But in general, if somebody talked to you about a solution like ABS back in 2008, what would have been the difference in your stance would it have been the same? Because you carry a lot of experience even before 2008 on the climate change capital fund and others.
It's a good question. I think back then, again, you talk about regulation and environmental protection. There have been laws and regulations for many years, but even today, there isn't a lot of regulation, or there isn't enough regulation around what you can and can't use. And even some of the products which are described as being biologically friendly or eco-friendly, they are toxic in an aquatic environment. And that has a downstream impact. Back then, I think I was much more focused on the sort of technologies around energy. Obviously, waste to energy was one of those, but renewable energy and whether it was wind or solar was much more of my focus, because that's where there was demand in the market, and that's where there was, the governments were looking to support the development of those inventions and the rollout of those products, and they have done that generally very successfully. But they always required what Bill Gates calls the green premium. You need to pay more today in order to get down the cost curve, the experience curve, where wind and or solar is competitive with other types of energy, notwithstanding the intermittency issues. So I think had ABS been presented to me back then, I probably would have been interested, but it certainly wouldn't have been a priority at that point. One of the things that attracted me to what we are now doing is the cost effectiveness of it. So it's the replacement of chemicals, toxic chemicals, which are not necessarily expensive to manufacture, but the process of manufacturing is energy intensive. The packaging with the plastics, single-use plastics, is it's not good. And I think that we are just much more aware now of the impact that we are having on the natural world. Biodiversity is much more in the front line than it has been, although it's still lagging behind the energy transition to clean energy, renewable energy. It's a bit behind that, but the impacts are massive, and I think we're just starting to really realize the effect that we have had and will continue to have for quite the foreseeable future. So if you've got a product which is cost competitive and is good for the environment, why would you not use it? And the bulk of the benefits of using the type of products which we're manufacturing are in the avoided cost. They may be a little bit more expensive than the current bleaches and aggressive chemicals, but those don't solve the problem, and they damage the infrastructure, and where you still have to go in and clear blockages because the products aren't working. It is our area of the renewal, the replacement. That's our core focus. And overall, we will save, using our products will save significant amounts of money over the natural annual cycle. So if you look at all of the costs associated with repairs and replacement, and then you compare that with using our products as a preventative maintenance solution, and it's the frequency of use. By creating these colonies of microbes, bacteria, which are effectively eating the waste. To them, it's food; to us, it's waste. They are doing that in a way that is kind to the environment, but effective. So a little and often weekly dosing is more effective than we've got a problem, let's fix it.
Understood. That makes sense. So when I was looking through ABS's website, specifically the case studies that you guys have put up there with respect to your partnerships with restaurants, with public institutions. So one of the questions that came up in my mind was, is the application of the solutions being provided by ABS limited to smaller institution, or is it applicable also to industrial manufacturing sites or uh, or bigger venues, I would say. So, for example.
So I don't think the size of the venue matters.
Okay.
We're talking about urinals, we're talking about toilets, we're talking about sinks, we're talking about showers, we're talking about grease traps, we're talking about oil and water interceptors for our hydrocarbon application. And the strategy, the dosing strategy is the same. It's a weekly dose of some amount to keep those pipes clean and odorless. So, it sort of doesn't matter. And I think what we have to do is to think from a systems perspective for treatment of waste. So if you imagine that every one of our products reduces the amount of sludge, and we call the waste sludge, in that particular, source point, upstream in wherever that pipe is that's blocked or could get blocked, and you multiply that, and if you assume we can reduce the amount of waste going further down the system is being reduced significantly, you're taking load off that system. And one of the biggest problems that we have today is that the architecture, the infrastructure for dealing with waste, the wastewater treatment plants upstream of that, are overwhelmed by people. It's a population growth challenge. More people, no more infrastructure than there was 20, 30 years ago in many places, is now overwhelmed. So you've got two fundamental choices. One is you invest significantly into upgrading the wastewater treatment facility, or you address it at source to reduce the amount of waste going into that system needing treatment. So it doesn't matter what the type of location. But if you're manufacturing, you've still got the things that people need to use. If you're an airport, you've got lots of people going through. We're working with airports, we're working with railway stations, we're working with large distribution centers, we're working with, every type of building you can think of. If they've got the basic issues and they've got the same facilities, it's our products work in all of those environments. So I liken it to thinking about decentralized energy, increasing the efficiency at point of use, point of demand. So I've got solar panels on my roof here, very efficient when the sun is shining, more than our needs are, and we export it, the surplus, into the grid. And when we need it, we then draw on the grid, and it works not very efficiently yet, but it will be. Likewise, with treatment of waste, if everybody used our products at source, and we use them in my home here very effectively, they work extremely well. But it's how do you incentivize people to do that, and where does that incentive come from, and why? So if you look at developing markets, very significant issues with sanitation, particularly in peri-urban or urban environments, but also in rural communities. Treatment of waste is very sort of primitive in many cases, and there's a lot of health-related issues. And in theory, by using our products in some sort of engineered solution, a sort of think of Portaloos and what they do, and you think about how you can treat the waste associated with those. How do you fix that into an urban, peri-urban, or rural environment? It's not rocket science. The deep biotech we do, the actual design of the thing that people use to wash in the facility shouldn't be too complicated. And also, how do we recycle the good stuff, part of that waste, and making that productive as opposed to it just going into wastewater treatment plants. And so there's a lot we don't know. There's a lot that we're learning. There's a lot that we've learned how these things actually work. But just going back to we're doing what's happening today naturally, and just turbocharging it to making it more effective.
Understood. That makes sense. And I think, one of the earlier CEOs that I was talking to, one of the things that he talked about with respect to waste management, with respect to sustainability, with respect to environment-friendly solutions, is that in general, if I talk about the industries, the Fortune 500, the Fortune 100 companies, they all have sustainability goals. They all have waste management goals. They all have affluent goals. And there are people who are supplying the technologies, companies like ABS, companies like other startups, what they're doing. So if there is a solution which is actually eco-friendly, which is cost-friendly, and if there is a problem, or if there is a problem that can be solved, so what's the disconnect here? Why is not all manufacturing, all major Fortune 500 companies using systems like ABS, products like, or solutions like ABS? What's the difference? One of the reasons that I got to know was that nobody wants to tamper with the bottom line. So they have responsibilities, they have goals, but as long as the bottom line of the companies who have sustainability goal, Fortune 500 companies who have these kind of goals, that does not move, only then the integration of solutions from the outside startups like ABS actually gets into picture. So is there an opinion that you also have here? Or rather, is there an experience that has made you identify that, hey, these are 1, 2, 3 hurdles for companies like ABS to actually get integrated into a larger setting, into more number of companies using ABS solution? Is there something like that you have experienced?
Part of it I think is structural. So most of the large companies, and many small and medium-sized companies as well, work with facility managers who look after the day-to-day cleaning and maintenance and everything, security, energy of their facility. And it may be more than one facility manager, FM, doing that job. And quite often you get a separation between the soft services, FM, and the hard services. Hard FM deal with the plumbing, the maintenance, things go wrong, they fix that. The soft services are doing more this, what I call the front of house, where they're doing the cleaning, getting rid of scale, getting rid of smell, etc., cleaning out of grease traps, all of that. And sometimes, if you are the soft FM and you are looking to try an innovative product, and as you say, most companies now have a sustainability agenda. They've set themselves hard targets. They've set themselves, by 2030, we are going to be reducing our energy consumption by X, or reducing our carbon emissions by Y, or increasingly now water security, water quality, water consumption is a target. More and more companies are factoring that into it. So we're playing into in theory, a willing audience. But as with the adoption of any innovative product, there's the whole question: does it work? Can we see how it works? Can we have a trial? Can we do X, Y, and Z? So you've got lots of small boats rising on the tide that will eventually become a flood, clean flood, hopefully. So it is as more companies use and see the benefit of these products, it will expand. There's no doubt about it, because at the end of the day, if it saves you money and it's good for the environment and it's good in the workplace from a cleanliness point of view, a lack of odors, why would you not do it? So you wouldn't do it if you are in a contract where you make your money fixing those problems, unless you have a gain sharing arrangement or something else where you benefit in the savings. You will logically extend, work within the contract you have, and then at the end of it, you'll renegotiate. And what we're starting to see now is that the bids and the tenders have a lot more in them around sustainability and all of that. So again, if you know what our products can and will do, then you are more likely to feed that into your proposal. And we are starting to get into the bid cycle of a number of these larger facility managers. So there's a natural evolution. I think it's a 2 to 3 year curve on that adoption, and we're probably coming into proper effective year 3 now, and starting to see this moving, in the case studies are increasingly persuasive and powerful. But so partly it's the the architecture of how these buildings are managed, who's managing them, but there is an inevitable move towards more sustainable outcomes. And if you can measure it, then you are more likely to be able to produce that compelling argument. And we have a growing number of case studies where we can quite clearly measure the costs and the benefits.
Understood. And I remember one of those case studies that you mentioned, being on your website, where you talked about one of your clients actually trying to remove the urinal smell, and they were flushing it every 20 minutes. And that resulted in a waste of water equivalent to 12 swimming pools over a year. So
where you have frequent flushing, it's and you can reduce it to 1 to 2 times a day.
Yeah,
it makes an enormous difference.
Absolutely.
And so there is a trend towards waterless urinals, which are fine in a low footfall environment, because the cartridges that they typically have, which have an enzymatic disc or whatever, works for small amounts. But if you have heavy footfall, that will get used up very quickly, and then your system can't deal with it. So although UriZap, one of our products, was designed for a waterless urinal, it actually works more effectively and efficiently where you're flushing occasionally, but still saving a lot of water. And even yesterday, I saw a new design urinal that measures very effectively that use and what's being used and when it needs to flush. And we can work with that type of technology to make things even more efficient and better.
I think that type of partnership would make real good sense in bringing up the numbers that can be actually shown to the people who matter, and then actually who can take a decision on the type of products that should be used. So that makes sense. Yeah. I think one question, or rather one insight that I was looking forward to talking to you about, is who are the stars of ABS? Are those the scientists? Are those the people who actually understand the contract management of side of things, and then figure out how more businesses can be brought into the picture? Who is it? And if it is the scientist, what does their daily life look like?
So without doubt, the scientists are our DNA. They are the rock stars. They are the people who are really not only identifying, within that waste that we're analyzing, what are the bacteria that are most effective? What do we need to do to turbocharge them? But there's a whole process that we've designed from TRL1 through to TRL whatever commercial scale 79, and now that we have got manufacturing in house, we can go through the whole life cycle. So we have the big brain microbiologists, biochemists coming up with the formulations. We then are testing that in the field. We're then seeing what works, what doesn't work. And then when you're looking at scaling up, you're looking at the packaging. It's not straightforward because you've got living organisms, your microbes, and there is once you've activated them, what's their shelf life? How long do they survive in the natural environment? How do you improve that? So there's a whole iterative process, and then when you're scaling up and you're freeze drying and then you're reactivating, what gets lost in that process? What's damaging those bacteria? And because we now understand and can control the end-to-end part of that, when we are looking at scaling up significantly and we are looking to contract manufacturing to complement what we can do in-house, then having that deep knowledge of that whole process then enables us to avoid things going wrong or more likely to go wrong in the future. So the science is the fundamental part of what we do. To give you another example, we were asked by a leading hotel chain in the UK to evaluate the mold remover market. Mold is, anyway, damp and stuff is a big issue, and it's pretty much everywhere to different extents. So we analyzed 35 different mold remover products. We then looked very closely at a deep dive into 10 of them. And then as a result of that, we were asked to develop a more effective, cost-effective remover product, which over a fairly short period of sort of 4 to 5 months, we've field trialed that product. There's some iteration required, perhaps a little bit of reformulation. But we're very close to having a solution that really works, that is non-toxic, non-pathogenic, and it doesn't damage the surface that you're looking to clean. And that's happened very quickly. Now, that is quite different to, for example, trying to solve the nitrates issue or trying to solve the hydrocarbon issue. And we have developed products in the lab that work incredibly well in a very short space of time, degrading hydrocarbons, degrading nitrates, nitrites, eliminating the gaseous fraction, which is important from a global warming, global heating perspective. But there's a longer learning cycle when you're doing field trials in the open environment. Outside, you need to go through the different seasons, the hot and the cold and the humidity and all of that, and see how it performs in each of those. And when I was talking a little bit about developing market and thinking about how to create a more effective waste management system and treating at source, again, understanding the mass balance and things like that is really important. So that's where our scientific expertise, allied with our engineering knowledge, is a very valuable combination. You can produce things that work in the lab, but they won't work as effectively outside of it. So we're very rigorous in our approach to all of these things, and it takes time. So you're probably from a start to finish on a product realistically a couple of years, where like with the mold removal, we've done it literally in 5 to 6 months. That is the exception. So, cleaning products, shorter term, going from the start to finish. There's a lot of stuff on the market, biological, eco-friendly stuff. We know quite a lot about it. We would like to think that we're a little bit more sort of rigorous in and careful with what we're putting into the market, that has been carefully tested. But you've got to stop somewhere, and then something that's good enough, and then you build on that. But the areas that really, from an ABS point of view and our mission, that are really interesting are those things in development. So the hydrocarbon, the nitrates, we're looking at solutions for PFAS, which is increasingly, people are aware of the problems with PFAS. We're looking at treatment of heavy metals, biomining, to extract the essential minerals coming out of either a mining or a manufacturing process, so we can recirculate that. And in agriculture, which is another area that we're starting to look at quite closely, biofertilizers is an area where there's already a lot of interest, but with the knowledge that we've got and we're building, how do we create biofertilizers that will be more effective, improve yields? How do we increase the methane fraction in an AD plant? We're developing things around that. We have a product that dissolves struvite, which is a byproduct from the AD process. It's a completely natural product, and it dissolves the struvite very quickly, very effectively, and you can put the dissolved struvite back into the front end of the AD plant, as opposed to having to get rid of it because you've got very toxic acids. So the future is really building on the platform we've established. We're not a single rifle shot company. We have a number of products we're developing, but they're all about, when you look at the 9 boundaries, you look at the chemical pollution issues, biodiversity loss, all that. We're feeding into improving that and hopefully starting to turn things around.
That makes sense. And I think, after talking to you, one of the things that actually came out for me was that you guys are sitting on a lot of knowledge and research and testing, field testing that you guys have done. So is there an offering from ABS that actually goes towards the advisory side of things, where you actually don't have products, but you are selling your knowledge, your intelligence? Is that something that companies can use through ABS?
Yes, absolutely. So we have a consulting practice. It applies all of the traditional, here's the problem, how do we solve it, and what is required. Ultimately, we want there to be a product that is part of that solution. So when you've identified what that problem is, and then you've done some tests on different things to see, can we design a bacterial formulation or a chemical formulation that will actually solve that? And then can we scale that up so that can be applied globally at large scale? That is where we want to be. So it's not consultancy for consultancy's sake, it's consultancy, the end in mind, as a product that solves global problems. So we are very keen and are already working with companies, contractors, environmental remediation companies who are dealing with these issues every single day. So, is there a more cost-effective, a more efficient way of dealing with that problem? Thinking about hydrocarbons and spills, there are products out there that do various parts of dealing with that, but can we design something that is more efficient? And those are sort of areas that we're looking at. We can design the raw product, the powder or the liquid or the bioblock, for example, that works effectively. And then it's, how does that work in that environment? So fats, oils, and greases are a good example where there's a significant problem. They build up. You have to either swap the grease trap out, or by using the enzymatic products, they dissolve the fats, oils, and greases, which basically just go downstream and they reform and they become fatbergs, and we know the complexity of dealing with that. So, by using our products upstream, you can prevent the source of that problem, because the bacteria turning the waste into water and some gas, carbon dioxide, is a more efficient way to go. Having said that, for the water companies, they've got all the water wells, they've got the pumping stations, they frequently get blocked up. So we've been trying one of the products we've got in a bioblock, which you suspend into the water well or into the pumping station. So it's dissolving slowly. So you've got remedial treatment over a longer period of time, which seems to be working well. Again, we're early days into the testing of that, but it does seem to be working quite well.
And that's an interesting concept. I think, that makes sense also from a lot of things. So your website mentions, ABS's website mentions patents. Now, so there are two questions linked to this. One is, what's your focus geography or jurisdiction right now? Is it UK and adjacent jurisdiction where most of your clienteles are? Is it going to expand? Is it going to go towards the developing countries also, or countries or areas that are catching up? Because, if you look at it from a perspective of attractiveness, from a business perspective, developing countries have less to spend on the sustainability part, more to spend on the progress part, as compared to the others who actually have regulations, who are developed, who don't have to actually think about basic work. So what's your focus area in terms of expanding the reach of ABS's products and solutions and advisory? One. And the second is, if in the near future, say, for example, in terms of 5 to 10 years, your focus is towards more on the developed side of things, or developed jurisdictions, then are you guys also thinking about partnering up by sharing your technology through patents with other companies on the developing side of the world also?
Yes, I think as you expect, there are a number of answers to this. We've started in the UK. We have a distribution agreement with an entity out in Australia for Australia and New Zealand. We have relationships in the US we're looking to develop. There's very significant opportunities there, as you would expect. We are involved in discussions in Romania, Japan. Wow. Nigeria is potentially a big market. And in terms of a developing market proof of concept, if everything goes according to plan and we get the right support and the buy-in from some of the key NGOs working in that area, in waste and pollution and sanitation, particularly, then we could quite quickly start a project carefully, methodically, to prove what works and how it works, and what you need to do around, again, iterations of because different bacteria thrive in different environments. So you can't, it isn't a one size fits all here. We have a patent today for Ureasat, which is our uric digester. We're in the process of going through that sort of international thing, and the plan is for all of our products that we will. But there's also a lot of know-how in the iteration and how you get to that final result, and then also the application of it to be most effective. So there's protection at different levels. Our plan is to be able to supply the core product, the bacterial nutrient element of it, to contract manufacturers who will then source in the other bulk materials required in the formulation. And yes, licensing that to entities wherever is a part of the plan, and we're looking into that right now to make sure that we are doing it cost effectively. Patenting globally is an expensive business. We've already had to defend our patent once, which we did so successfully, and yeah, so it's important we get it right. Having said that, we are not going to solve these global problems on our own. We need partners. So we are looking, to have those discussions with large multinationals, corporates across the different sectors that we are operating in or will be, to champion those products. We would be happy to white label. It's there are lots of different ways you can organize what we're doing to get to scale. So, if there was a large corporate who wanted us to design something very specifically for them, the brand they've got, whatever, we will be able to do that. And yeah, and all of that will need some form of thoughtful protection.
Understood. That makes sense. And I think that concludes all the questions that I had, at least for you. For this discussion. I think, only one observation. After reading your website, you got very, very catchy product names. So I did not expect something like those from a scientific company, which is actually championing science. But those are really catchy names. And I think, that's a good way or good start to actually letting people know that, hey, this is exactly what it does. And apart from that, I think, I gained a lot of knowledge with respect to wastewater management, wastewater saving, preventive maintenance, and then preventive saving of energy. Those are things where the devil is in the details. There are a lot of startups that we analyze when we are working for our clients. But I have understood that unless and until we are actually applying a lens of subject matter expertise, which you have and which you have imparted in this in this conversation, I don't think simply looking at startups and their solution makes sense. So that was the aim, to bring out the finer details of the working of these type of organizations, startups, letting people know that, hey, it's not just the bacteria which are doing the work. It's actually the whole ecosystem where there are finer nuances and details, regulations, soft service providers, hard service providers, who all come into picture, and then the innovation actually becomes the champion for solving things, right? So very informative.
Yeah. I agree, and it's a multi-dimensional problem: energy pollution, biodiversity loss, climate. It's all interrelated. So when we think of our products, they're solving lots of different issues, and in aggregate, they're helping to solve, in hopefully in a very large way. But we just, it needs to become common usage, commonplace, and it takes time to get that level of adoption. But we're in a good place. I've got a great team. It's still very early days, but we've already proven that the business case, we're proving the use case, we're proving the scientific case, and we are scratching the surface of what is possible. So it's an exciting time.
It is. And I think, I would love to see you guys reach that place that you just envisioned for us. And I think, with respect to the solutions, you guys are doing great. I wish you all the best. And thank you again very much for your time, Gareth. I think this was very informative for me, and in general for the audiences who are going to look at it. But in general, great talking to you, Gareth. And thank you again very much for your time.
Pleasure, and very nice talking to you.
Thank you.
Sure.
Cheers.
Bye.